All right, we're continuing topic 2.3, and we're going to now look at Explore 2, part CD, and the reflect questions. So now graph g of x. Notice we're multiplying by in the inside by 1 over b. B is the parameter. We're going to let it equal 2, so we're multiplying it by 1/2. So we're going to complete the mapping diagram. To complete this, you now need to find the inputs that produce the outputs. You work backwards, you're basically multiplying by 2. And then in general, I don't use this one as much. We tend to do the vertical stretch and compression. I'm going to show this to you, but no, this one isn't going to, we're probably not going to focus on this one quite as much. So I'm going to multiply by 1/2. So when I multiply -2 by 1/2, I get -1. When I multiply 2 by 1/2, I get 1. To get 3, something I multiply 3 by to get 1/2 would be 6. And something I multiply by 1/2 to get 5 would be 10. So I'm going to go ahead and I'm going to plot this input and this output for my g function. So -2, and then I'm going to go to -2. And then I'm going to go 2, and I'm going to go to 2. I'm not sure I did that right. 2, 2. Yep. 6, -2. And then 10, 2. All right, you'll notice this time it has the same range values there, but the domain values have increased. It has, like, it's pulled it left and right. So we would want to say that this is a horizontal stretch, okay? So when b is greater than 1 or positive, the graph has a horizontal stretch by a factor of b. Okay. So what would you expect the graph of b of x is related to the graph when the number is between 0 and 1? So if it's going to stretch horizontally, that means we haven't done any compressions yet. If we were going to do that, it would probably compress. So when b is between 0 and 1, I wrote that wrong. Okay. The graph will horizontally compress by a factor of b. All right, let's take a look at the reflect questions here. So suppose a function